Hi, I'm Professor Devin Kamanaris, a member of the Biochemistry Department at Alma College. I'd like to take some time to talk to you today about an exciting program we have here at Alma College, and that is our participation in the iGEM competition, which is a team-based, student-driven yearly event in synthetic biology in which students get together and design a project which attempts to solve a real-world problem. iGEM stands for the International Genetically Engineered Machine Competition. Here, machine doesn't refer to a piece of lab equipment, but instead refers to a living system, a microbe which has been engineered to carry out some useful behavior, to act as a sort of machine or a new piece of technology. iGEM is an international event. It had some humble beginnings, but over the past 15 years, it has grown to be an event which attracts between 300 and 400 teams from across the world, both collegiate teams, high school teams, community labs, featuring thousands of students, mostly undergraduates, all working together on different projects, again, from across the globe. These projects tackle a wide range of real-world problems. This includes creating microbes or engineering microbes to degrade plastic waste or clean up other forms of pollution, creating microbes which will produce biofuels or other useful metabolites. I was actually the other day discussing with students online some aspects of a project from last year, another team which created a sensor, a device which would sense different types of pathogens in air samples, both quickly and accurately. These can be deployed, for example, in hospitals. So solutions to problems, real pressing problems, but creative synthetic biology solutions. Another example of this is the project that Alma's team tackled last year. And this was to engineer or create an enhanced probiotic which would help to treat certain forms of heart disease, or more accurately, help prevent these different forms of heart disease. This project with the students called Plaque Attack not only involved getting a lot of the science right and involved looking at both molecular biology, microbiology, human physiology, and nutrition, but also students explored deeply some social issues surrounding this project, thought about what the impact of this project would be on the local and also broader community, and thought deeply about how would they best communicate the ideas behind their project. Again, this involves not only thinking about the science, but also designing artwork, logos, banners, posters, and websites. This is not something that's unique to this year's project. In fact, every iGEM team has to grapple with these different issues. It makes iGEM inherently interdisciplinary. And it makes sense. iGEM is focused on solving problems, and to do that you need not only the science, but you need to integrate a lot of other things to solve real-world problems. Now, most iGEM teams grapple with all of these issues alone, as an extracurricular activity or as students getting together over the summer. At Alma, we have taken steps to integrate iGEM into our curriculum. So whether it is students in advanced biochemistry or molecular genetics in the biochemistry lab, and some photos of which are shown on the left, working on the hard science components, or if it's students that are meeting in the club or over the summer, or throughout the academic year, grappling with other issues like brainstorming project ideas, fundraising ideas, how to communicate the project, how to design artwork, how to design the website, how to carry out any of the other myriad of tasks involved in an iGEM project. Again, this is done within the class, outside of the class, and the discussion goes back and forth between those two elements. To encourage students from other majors to participate, we even have a minor, the biotechnology minor, which features courses that are very heavily centered around iGEM, courses like molecular genetics and the Biotechnology Journal Club. All of this hard work and student participation eventually leads to students attending the iGEM Jamboree in the fall, where students get a chance to, both on the website and the poster and in an oral presentation, present the hard work that they've done over the year, It's a great opportunity to meet students from across the world. It's a fantastic networking opportunity. It's also a lot of fun. It's not your typical science conference. There are students that show up dressed as mascots. There's a lot of creative ways of presenting the work. And here you can see some pictures of Alma's team at the Jamboree from last year, their poster and a picture of them presenting in front of an audience, an international audience of over 100 people. All of this hard work earned Alma a silver medal last year in the competition. This was actually the best result of all the iGEM teams in Michigan and equal best of all the teams in the Midwest. And I'd invite you to join Alma and join the Alma iGEM team. We are open to all students, all majors, all years. And hopefully you can help us earn a gold next year or in future years. If you want to learn more about iGEM, you can go to igem.org. You can visit the Alma iGEM website if you want to learn more about that, about last year's project. And if you'd just like to talk more about iGEM in general or have any other questions, please feel free to email me. I'm always happy to talk about iGEM. I could talk about iGEM all day long. All right, thank you for watching and have a great day.